This is just a demonstration of the transformation of functions graphically. So here my goal is to graph this g of x function over here, negative 2 times the quantity x minus 3l cubed plus 4. So the base function here is x cubed. So I have this set up so I have a function right now of x cubed, and I have this h and this k and this a and this n. And let me explain what each one of them does. H is going to be the number that goes inside of the parentheses next to x. K is going to be the number on the outside. And A is going to be either greater than 1 or between 0 and 1. And then N is just going to flip it back and forth between positive and negative. So when I do these things, it's going to change f of x. And what I want to eventually get to is what g of x looks like. Let's see what each piece does. So let's turn on my function. That's what an f of x equals 1x cubed looks like. It's the base function. And if I move h in the positive direction, the graph is going to move positive. Now be careful here. Inside the parentheses, it's actually written as x minus 3, but I'm moving h to be positive 3. So basically what happens is if it's inside the parentheses, it's going to go opposite direction. And in this case, since it's affecting the x, it's going to go left or right. So as h gets bigger, x minus h will force this graph to go to the right 3 units. All right, now k, on the other hand, if we make it negative, the graph goes down. If we make it positive, the graph goes up. So the number on the outside, not inside the parentheses or not inside the function, is just going to force the entire function to go up or down in the same direction as the sign. So as h goes negative, it'll become x plus on the inside, but it'll move 2 to the left. So x plus 2, 2 to the left. All right, so those are the easy motions of a graph. Left and right, the number inside next to x. Up and down, the number outside of the parentheses will force the graph to go up and down. Now let's deal with n first. N is pretty simple too. N is going to force the graph to go its normal direction or flip it. Now to describe the flip, some people think there's an order to a transformation, but I try to remove the order because things get a little confusing. So what I do is I create these new axes, and we're going to call it x prime and y prime. And basically all x prime and y prime are is the value of k would be x prime, and the value of h will be y prime. In other words, x equals 3 gives you this line right here, and y equals 2 gives you this line right here. And the intersection of these two lines is the only point that you plot for the graphing of these functions. Because they're sketches, they're not literal graphs. And this will help me with the A part. The A part is probably the most confusing out of all of them. Here, let me move this up a little bit further. Up a little bit further. There we go, get it away from A. Now A, if it's equal to 1, it just stays right on the base graph. But if A is different than 1, we need a reference. So we're going to have to put in a reference graph. And I'll show you what it looks like. Let's make A bigger than 1. And you'll see that the graph pulls away from where it originally was. So as A goes between 1 and larger numbers, the graph is getting closer to the vertical asymptote here, or I'm sorry, the vertical axis, my y prime. So as A gets bigger and bigger, it gets closer and closer to that y prime axis. Now let's go the other direction. Let's put it back at 1. So if A is between 0 and 1, what it does is it gets closer to the horizontal axis, in this case x prime. So between 0 and 1, it gets closer to the x-axis, or the horizontal line. And if A is bigger than 1, it gets closer to the vertical line. So that's what A does. So let's graph this g of x negative 2 parentheses x minus 3 all cubed plus 4. The first thing you have to recognize is the inside is the left and right motion. So we're talking about h here. So h is going to be positive 3 because on the inside it's the opposite direction. So this graph should go to the right 3 units. So let's make h equal to 3. And then you'll see the graph move over 3 units, y prime moves over 3 units, and the first thing you can draw is the y prime line on a piece of graph paper. Then we'll take care of the k. The k is the number outside the parentheses, the 4 in this case. So k is going to equal positive 4. Let's start over again. So it's going to go up 1, 2, 3, 4. Now you can draw two different things. You can draw the x prime line and the intersection of the x prime and the y prime lines. So this is the only point you draw on a piece of paper besides these dotted lines and your function. Alright, I already have this set to be negative, but if it was positive, this would be the standard position of a cube curve, translated, 3 to the right and 4 up. But this is a negative 2, so I want to make my n negative. So it flips upside down. So what was on the top goes to the bottom, what was in the bottom goes to the top, and it just flips over this line. Alright, so the next setting is this 2. We took care of the negative, we took care of the 3, we took care of the 4. So the 2 is the a. Now when I start moving the a, the graph is going to move away from that dotted line. So if it's bigger than 1, it gets closer to the vertical. If it's smaller than 1 but bigger than 0, it gets closer to the horizontal. And what I mean by horizontal is this line. And when it gets bigger than 1, what I mean by the vertical is this line. So here a is equal to 2, so this, too far, right there, would be the graph. Now sketching wise, you just have to make sure your graph ends up on this side of the green dotted line closer to the vertical, and on this side of the green line closer to the vertical down here. And that would be what I'm looking for in the sketch. So the general shape on the right side of the dotted line, the original function, and the axes and this one point.